So today in class, we first finished up our definitions that we started yesterday. If you remember, yesterday we said a parent function was the most basic function in a family. And down here are some pictures of the most basic ones that we'll be working with in this section. We may have also gotten to transformation, I can't remember, but what we basically said is a transformation is something that changes the size, shape, position, and orientation. Okay? To clarify that a little more, translation is basically a slide. This is your left or right movement, up or down movement. It changes position, but that's it. It doesn't change there's no reflection, it doesn't make it wider or narrower, it just changes the position. Now, a reflection is when your graph seems to flip, either over the x-axis or the y-axis. But basically, this is what we're talking about when we're talking about changing orientation. It's a flip. Now, a vertical stretch or shrink. This is when the graph gets more narrow or wider. Okay? A vertical stretch is when you have multiplied by a factor bigger than 1. So, for example, on a quadratic, if your parent function was y equals x squared, a vertical stretch might have been if you had y equals 2x squared. Okay? The same time, a vertical shrink is when you multiply by a factor between 0 and 1, or like a fraction. So instead of y equals x squared, we might have y equals 1/3 x squared. And so what we practiced on today is looking at describing how the new graph changes from the parent function. When we talk about changes, we're talking about, did the size or shape change? Did the position change? Did the orientation change? And I really just want you to tell me, out of those 4 things, which ones changed. So if you go to the next page, let's look at the first example. The first example says, identify the function family to which f belongs. Then compare the graph of f to the graph of its parent function. Okay? Well, looking at example number 1, you can see that this is a linear function. So that is the family it belongs to. Now, what I find easiest is to, after I've identified the family, I go ahead and draw on the parent function. Well, the linear parent function goes through the origin and looks like this. It's the graph of y equals x. And again, don't let the f of x freak you out. You can change it to a y if you want. And now I'm just going to go through my checklist. Okay? Did the size or shape change? Well, no. The size or shape didn't really change because it's just a line. Okay? Did the position change? Well, yes, it did. The original function crossed the y-axis at 0, 0. The new function is crossing at y equals 8. So that is a translation 8 units up. That's how you would describe position. So it translated 8 units up. Another thing that changed is its orientation. Notice that the original function has a positive slope because it's going up from left to right. Our function has a negative slope, so that would be something you'd want to mention. It has a negative slope. Also, in regards to the slope, this one has a slope of 1. This one has a slope of negative 1/4. Another thing we could also say about this in regard to orientation is that the slope is less steep. That would probably be also something you would want to include. So just use that transformation definition as a checklist. Did I talk about size and shape? Did I talk about position? Did I talk about orientation? And you only really have to talk about the ones that actually changed. So let's go down and look at number 3. Number 3, this belongs to the absolute value family. And so that's going to help me draw the parent function. The parent function, if you look on the previous page for absolute value, looks like this. All right? And so let's go through and see what's changed. Well, first of all, did the size or shape change? Well, you can definitely tell that the new graph is more narrow. So what that means is there was a vertical stretch. And if you look at the equation, it's because they multiplied by 5. So we will just say by a factor of 5. Okay. Now, as far as position, our new graph is still at 0, 0. So it didn't move left or right or move up or down at all. So there was no change in position, so I don't need to write anything. For orientation, there was no reflection or flip, so there was nothing to write about orientation. So the only thing that changed is that the shape changed. There was a vertical stretch by a factor of 5. You don't always have to write a lot down. Okay? Another thing we talked about, if you come down to this next section, it says graph the function and its parent function, then describe the transformation. Okay? Well, we talked about what to do in case you don't remember how to graph something. Certain functions have certain ways you can graph it. One method that never fails is making an XY table. And again, don't let the f of x freak you out, just change it to a y. So for example, let's say you looked at this one and you could not remember what type of function it was or how to graph it. Let's just make an XY table. When you make an XY table, you can pick whatever x's you want. Pick something easy though. For example, in this one I did -1, 0, and 1. What you're going to do is you're going to plug those in and find the answer. Okay? When I use -1 for x, I'll have -1 minus 7. That gives me -8. That's an ordered pair. I can plot that on my graph. I'd go to -1 down to -8 and plot my point. Now I'm going to plug in 0. 0 minus 7 is -7. There's another ordered pair I can graph. When I plug in 1, 1 minus 7 is -6. There's another ordered pair. And that's probably enough, and you can see that your graph is a straight line right here. And since we can now tell that it's part of the linear family, I'm going to graph the parent function. And again, you can look at the page before if you need to. This is the parent function, y equals x. And so now that we can look at both, we can describe how it changes. And again, go through your checklist. Did the size or shape change? No, it did not. Did the position change? Yes, it did. The original function was at 0 on the y-axis. The new one's down at -7. So we would say that this translated 7 units down. Okay? The next thing we would look at is, did the orientation change? Was there any change to the slope? And if you look at this, no, there was no change. The parent function has a slope of 1. The new function also had a slope of 1, so there was no slope change. So the only change was that it translated 7 units down. If you go to the next page, another example we did was example 11. It says identify the function family of f of x equals 1/3 times the absolute value of -x plus 4 and describe the domain and range. It says to use a graphing calculator to describe your answer. You can also use the grapher on the computer that we did yesterday. All right? And so what I did is I first identified that this is the absolute value family. Okay? And then I went ahead to the grapher and I graphed this on the computer. And I looked at the graph, and I don't have a graphing calculator next to me, so I'm going to sketch this, so I apologize. And what I noticed is I ended up with a graph that looks like this. All right. Didn't ask me to do a comparison to the parent function. This one actually asked me to give the domain and range. Now, if you remember from yesterday, domain is what kind of x's can we put in the problem. And we already talked about yesterday how you can take the absolute value of any number, positive, negative, fraction, decimal, and so our domain is still going to be all real numbers. Okay? Now as far as the range, remember range is what kind of answers are coming out. Now, if you look at the parent function, the range for an absolute value parent function was y is greater than or equal to 0. That's because all of our answers were 0 or bigger. If you look at our graph though, our graph doesn't start at 0. Actually, our lowest answer or the lowest value on our shape is 4. And then it gets bigger from there. So our range is actually going to be that my answers have to be greater than or equal to 4 because that is the lowest point that actually shows up on my graph. Now for your assignment, the assignment is on Blackboard. You will need the online book. And remember what you do is you go to bigideasmath.com, click on the green student button, and when you go down to the home access, it should say Common Core High School. And then you will choose our book and you need to find the 1.1 exercises. And the problems, and this is on Blackboard, and I'm going to actually put a screenshot of these problems on Blackboard as well soon. I'd like you to do pages 8 and 10. I'd like you to do 3 through 30, multiples of 3, and then it was 36, 37, 39, 40, and 53. Not all of these are graphing. Some of them are just asking you to put it in the graphing calculator on the computer and do a comparison. But those are the problems I'd like you to look at for tomorrow.